Hello, space enthusiasts and curious minds. Today, we're diving into an exciting topic, the search for habitable exoplanets. As we look beyond our solar system, we're constantly searching for planets that could support life. Join me as we explore why, despite the discovery of thousands of exoplanets, none have been confirmed as habitable just yet. Strap in, and let's journey through the cosmos together. Today, the internet is brimming with astronomical myths. There's no escaping it. From poorly informed articles spreading outright falsehoods to those ever-multiplying AI-generated space channels, misinformation is rife. For instance, take the planet J1407b, a supposed celestial body debunked years ago. I've even dedicated a full video to dispelling the myth of its existence. My passion for truth fueled the creation of this channel. It's designed to combat these cosmic fallacies head-on. Since we've already tackled J1407b, it's time to widen our scope. Today we dive into the so-called habitable exoplanets, a topic teeming with sensational claims. You've probably heard someone somewhere proclaim that NASA has discovered Earth 2.0, or that there's a planet even more conducive to life than our own Earth. Most of these claims cluster around notable names like Kepler-22b, Kepler-186f, Proxima Centauri b, and the entire TRAPPIST-1 system. However, what many don't realize is that despite being the best candidates among a bad lot, these planets are actually terrible options for habitability. Join me as we explore these exoplanets in depth, breaking down the myths and presenting the science behind each one. Let's set the facts straight together. Let's clear the air. Not all that glitters in the cosmos is gold, and today we're going planet by planet to debunk the habitability of so-called habitable exoplanets. After that, we'll spotlight a few stellar candidates that might actually stand a chance. First up, the infamous Kepler-22b. Positioned snugly in its star's habitable zone, Kepler-22b might seem like a dream with just the right conditions for liquid water. But that's where the similarities to Earth end, and honestly, it should have been struck from the list of potential homes away from home long ago. For starters, its mass remains a mystery. We know it's less than 9 times Earth's, but that's about it. However, its radius is a known giant at 2.3 times that of Earth. Typically, rocky planets don't balloon to these dimensions. With Kepler-22b's probable mass, it's unlikely to be a rocky planet at all. More likely, it's a Neptune twin, sans solid surface, possibly an entire world engulfed in ultra-deep oceans, stretching hundreds of miles. Sure, these conditions suggest water might exist, but don't be fooled. Such extreme oceanic environments are far from conducive to life as we know it. Let's dive deeper into these celestial bodies and separate science fiction from science fact. Life's cradle isn't just about the right temperature. It demands a fiery spark. From hydrothermal vents in the abyssal deep to hot springs bubbling on pristine surfaces, volcanic activity is essential for kickstarting life. But imagine trying to find these life-giving features when your volcanoes are buried under an ocean so immense, the pressure turns the bottom into solid layers. This is the predicament with Kepler-22b, a world that may be more akin to a smaller version of Neptune or an ocean planet where the water is far too deep for its own good. Despite basking in the Goldilocks zone, that sweet spot where temperatures could allow water to remain liquid, Kepler-22b likely lacks any other conditions necessary for life. This planet, while temptingly placed, falls short in providing the environments we believe are vital for life to flourish. This point underscores a crucial lesson for our exploration. Simply residing in a habitable zone doesn't guarantee a planet's livability. The habitable zone promises only potential for suitable temperatures, nothing more. It does not account for the planet's water content, atmosphere, necessary atmospheric pressure, size, or any of the myriad factors that actually make a planet hospitable. From our current understanding, truly habitable planets are a rarity. Astonishingly so. Now let's continue to the next exoplanet candidate and see how it measures up to our stringent criteria for habitability. Next on our celestial tour is Kepler, 186f, which at first glance offers more promise than Kepler 22b. This exoplanet boasts a mass approximately 1.5 times that of Earth, suggesting a solid surface beneath its skies. Of all the planets we're exploring today, Kepler 186f emerges as a strong contender for habitability. However, even the best candidates have their flaws. Kepler 186f's equilibrium temperature hovers around a frigid 120 degrees, about 85 degrees, making it cooler than a typical day on Mars. In fact, it sits midway between the harsh climates of Mars and Jupiter. While these figures are based on estimates assuming no atmosphere, the presence of one could potentially trigger a greenhouse effect, warming the planet. But here's the catch. Even with an Earth-like atmosphere, the conditions on Kepler 186f could still be exceedingly cold. And if we were to increase the atmospheric thickness to warm it up, there's a precarious balance at play. Too much atmosphere and we could end up with a runaway greenhouse effect, transforming Kepler 186f into a Venus-like inferno. Thus, Kepler 186f presents a paradox. It's either too cold to support life, delicately balanced on the brink of habitability, or veering towards a hellish, inhospitable state. Caught between these extremes, the true nature of Kepler 186f remains a tantalizing mystery in our search for a second Earth. While there remains a glimmer of hope for Kepler 186f's habitability, I'd advise tempering your expectations. Interestingly, if Kepler 186f were habitable, it might feature exotic red vegetation due to its unique starlight. Yet, this intriguing possibility also underscores a significant issue in exoplanet research: the overwhelming focus on potentially habitable planets. Whenever Kepler 186f comes up in conversation, its siblings, Kepler 186b, c, d, and e, rarely make the cut. These planets, ranging between 1 to 2.5 times the mass of Earth, orbit closer to their star than 186f. Each of these four worlds could be as captivating as Mars, Venus, Titan, or Mercury, yet they're overshadowed by the habitability hype surrounding their famous sibling. By fixating solely on planets like Kepler 186f, we're neglecting thousands of other fascinating celestial bodies across the cosmos. The narrative takes an even more dramatic turn with Proxima b. In my view, Proxima b is the least likely candidate for habitability on our list. In fact, it's not just uninhabitable, it's so hostile that Mars and Venus might seem like utopian retreats in comparison. And believe me, that's no overstatement. The very notion that we even consider the habitability of such an extreme world highlights the audacious nature of our quest across the stars. Considering Proxima b as potentially habitable seems almost ludicrous to me given its plethora of issues. It's like the universe conspired to make this planet utterly inhospitable. While we can't be absolutely certain until we fully understand its environment, the evidence we have so far paints a grim picture. From its turbulent star to its precarious orbit, everything seems to be working against Proxima b. Add in the presence of a second planet, Proxima c, and the odds get even worse. I've delved deeply into this topic in another video, which you can find linked in the top corner. If there is an asteroid belt between Proxima b and Proxima c, it could be a relentless source of incoming asteroids for Proxima b. Over time, these impacts alone might have been enough to sterilize the planet. Given all these challenges, it's hard to imagine Proxima b being habitable. We still don't know much about its environment, since the planet doesn't transit its star from our perspective, making it tough to study its atmosphere. However, it's likely that Proxima b doesn't have an atmosphere at all. These issues are common among planets orbiting red dwarfs. Next up is the fascinating TRAPPIST-1 system, one of the most intriguing discoveries to date. With 7 Earth-sized planets orbiting its star, and 3 of them in the habitable zone, it's a system ripe for exploration. For a more detailed look, check out my grand tour of TRAPPIST-1 video. But like Proxima b, these planets face the challenges posed by red dwarf flares. TRAPPIST-1, although relatively calm for a red dwarf now, is about 8 billion years old. It was likely far more active in its younger years, subjecting its planets to intense flares and volatile conditions. This past activity could have severely impacted the habitability of these worlds, just as it has for Proxima b. When TRAPPIST-1 was young, the planets in its system faced a harsh environment similar to Proxima Centauri's. Over its 8 billion-year history, TRAPPIST-1 likely stripped away the oceans and atmospheres of any planets that once had them. The James Webb Space Telescope provides evidence for this. TRAPPIST-1b, the system's innermost planet, is almost certainly airless, resembling a super Mercury. This isn't shocking, but the situation looks grim for TRAPPIST-1, C, D, and G as well, all showing signs of being airless. We don't have enough data on TRAPPIST-1, E, F, and H yet, but if the trend continues, it's likely these planets are also devoid of atmospheres. Even though TRAPPIST-1c might hold on to a thin atmosphere, as I discussed in my grand tour of TRAPPIST-1 video, this doesn't significantly alter the overall bleak picture. It appears that most TRAPPIST-1 planets, including those in the habitable zone, are airless. However, they might still have volcanic activity, which adds an intriguing element to the system. Just because they probably aren't habitable doesn't make the TRAPPIST-1 system any less fascinating. It's just not the best place to search for life. Next up on our cosmic journey is K218b, and it's, with a mass over 8 times that of Earth, K218b is far from Earth-like. To put it in perspective, that's half the mass of Neptune, making its chances for habitability slim since it's likely an ice giant or an ocean world similar to Kepler-22b. However, K218b stands out because the James Webb Space Telescope detected potential evidence of dimethyl sulfide, a possible sign of life. But let's clear up the hype. The James Webb Telescope did not directly detect dimethyl sulfide. It found hints that suggest its presence, but this is far from confirmation. The scientists behind this discovery have been cautious, only noting tentative evidence, not definitive proof, of dimethyl sulfide. So any claims of a definitive sign of life are pure clickbait. James Webb also observed potential signs of a water ocean on K218b. Again, this isn't confirmed, and recent analysis suggests that oceans of lava, not water, might better fit the data. I've discussed this more in my Ocean Planets video, but essentially K218b is most likely an uninhabitable super-Venus with relentless lava oceans rather than a paradise for life. Despite the buzz, K218b is far from the habitable utopia some headlines might suggest. Now let's move on to our next cosmic destination. Given the uncertainties surrounding many exoplanets, I left out some candidates we know too little about. However, after months of research, I discovered one exoplanet with a genuine shot at being habitable, TOI 700d. Now, I realize this might seem contradictory since TOI 700d orbits a red dwarf, the same type of star that led me to dismiss Proxima b and the TRAPPIST-1 system. But TOI 700d's situation is different because its star is a young red dwarf. This distinction brings several advantages that enhance TOI 700d's habitability prospects. First, the young star is much brighter than an older red dwarf of the same size. This brightness allows TOI 700d to orbit farther from its star, reducing the risk of atmospheric loss and tidal locking. Moreover, TOI 700d receives nearly the same amount of energy from its star as Earth does from the Sun. While we initially thought TRAPPIST-1c would be Venus-like for similar reasons, this hasn't proven true for TOI 700d. In summary, TOI 700d stands out among potentially habitable exoplanets. Despite my skepticism of red dwarf systems, the unique conditions of TOI 700d's star offer a promising environment for habitability. Now, let's delve deeper into what makes TOI 700d such a compelling candidate. TOI 700d receives an Earth-like amount of energy from its star, which is remarkable. It's about 70% more massive than Earth, still likely rocky but large enough to retain an atmosphere more easily. Its size and the youth of its star suggest it's geologically active, a crucial factor in building and maintaining an atmosphere. Another intriguing factor is the presence of TOE 700c, a second planet in the system. At about 7 times the mass of Earth, TOI 700c likely consumed most of the inner system material, making it improbable for other planets to form nearby. This indicates that TOI 700d must have formed further out from the star. In forming further out, it would have encountered more volatiles like water, enhancing its chances of developing a rich atmosphere and oceans. With all these factors, TOI 700d stands out as a promising candidate. While many different environments are possible, TOI 700d is the one exoplanet I can genuinely envision as an Earth-like world with oceans and an atmosphere. This exploration serves as a crucial reminder. Just because a planet is in the habitable zone doesn't guarantee it's potentially habitable. Most of the time. Most of these planets are probably as inhospitable as Mercury, Venus, and Mars, if not worse. Habitability is incredibly rare. Is it possible? Absolutely. But so far, we haven't found any truly promising candidates. So, next time you see an article claiming we've found Earth 2.0, scrutinize it closely. Look at 3 critical factors: the planet's size, its temperature, and the type of star it orbits. These 3 elements are key in determining a planet's potential for habitability. Other habitable planets are out there, and I firmly believe that one day we will find a truly Earth-like world. But as of now, we haven't discovered any yet. A habitable exoplanet, often termed an Earth-like planet, is one that can potentially support life as we know it. This doesn't just mean water and a breathable atmosphere, but also the right conditions for stable, long-term environments. Scientists use the Goldilocks zone to describe orbits where planets can maintain liquid water, a crucial ingredient for life. However, finding these conditions outside our solar system is a challenging feat. The main obstacle in confirming a planet as habitable is the vast distance separating us from these celestial bodies. Even with advanced telescopes like the James Webb Space Telescope, we can only infer certain characteristics based on the planet's orbit, size, and the light it reflects or absorbs. This data gives us clues about the atmosphere and possible water presence, but definitive evidence of habitability is still out of reach. The atmosphere of a planet plays a crucial role in its ability to support life. It must not only contain water vapor, but also block harmful cosmic radiation while trapping enough heat to maintain a stable, moderate temperature. Analyzing atmospheric components from light years away complicates the search for a truly habitable exoplanet. As of now, no exoplanet has shown all the necessary atmospheric conditions for human-like life. In the hunt for habitable planets, astronomers sometimes encounter false positives. These are planets initially thought to be in the habitable zone and possess Earth-like qualities, but later found lacking one or more essential elements. Misinterpretations of data due to cosmic phenomena or limitations in technology can lead to premature excitement about a planet's habitability prospects. Despite these challenges, the future of exoplanet discovery is bright. With advancements in space technology and missions, such as NASA's upcoming Plato mission aimed at discovering Earth-like planets, our understanding and capabilities are only improving. The quest for a habitable exoplanet continues, and each discovery, habitable or not, brings us closer to understanding our place in the universe. One of the most critical factors in determining the habitability of an exoplanet is the presence of liquid water. Water is essential for all known forms of life, and it acts as a solvent for chemical reactions that support life. Scientists focus on finding planets within the habitable zone, where conditions might allow liquid water to exist. However, simply being in the habitable zone is not enough. The planet's atmosphere, pressure, and composition must also support the existence of water in liquid form. A planet's size and mass significantly impact its potential habitability. If a planet is too small, it may not have enough gravity to retain a life-supporting atmosphere. Conversely, if it is too large, it might be a gas giant with no solid surface for life to thrive. Earth-sized planets, or slightly larger, super-Earths, are considered the best candidates for habitability because they can maintain a stable atmosphere and support geological processes crucial for life. Welcome to Blasovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blasovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q&A sessions with experts. Your membership will grant you the chance to participate in live Q&A sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos, and join us in unraveling the secrets of the universe. Become a Blasovia Science TV member today, and together, we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comments.